Okay, so now we'll work on this one. We have to start with a chemical reaction. So it says write a balance equation representing reaction between solid copper. So solid copper means it's going to be the solid copper here, Cu. Um, clarify it. So solid copper means solid copper. It's reacting with nitric acid, and acids are always aqueous. You know that. So that's going to be HNO3, and that's aqueous, right? And that's going to go into the aqueous copper ions. It's Cu2 plus aqueous and nitrogen monoxide gas. Okay, so nitrogen NO, that's in the gaseous form. Now I have to see what's going on in terms of the oxidation and reduction. And we have done it previously, so we have to look at the copper first. So copper is definitely loss of electron. Initially, copper was in 0 oxidation state, 2 plus 2 oxidation state. The loss of electrons, the reducing number is going up, means oxidation. And if I look at here, in this one, I have to assign the oxidation state for the nitrogen, right? Because oxygen, hydrogen, I'm not going to look at. So if I see here, there's 3 oxygens here. So definitely, because that's the second reactant here, so it's going to be I really do not really need to do it, but I will see how many electrons are being gained, because reduction is definitely going to happen here if the oxidation is happening on the other reactant. But that means oxygen is to have 3 oxygens here, each is -2 times 3 is going to be -6, and equal should be 0. It's a neutral compound, and hydrogen is always +1, so the nitrogen is going to be +5, right? And that's how you're going to get it equal to 0. And if you look at it here, it's -2 for the oxygen, and then it's going to be +2 for the nitrogen. So what's going on with the nitrogen is from +5, nitrogen is going into +2. So it's a loss of, it's a gain of 3 electrons, okay? 3 electrons are being gained. Okay, I understand that part. So nitrogen is gaining 3 electrons, so the reduction is happening here. So now I understand that part. So I can write down my 2 half reactions now, right? So when it comes to write the oxidation, it comes to write the half reactions. The first reaction is copper, and that's going to go into Cu2 plus, means loss of 2 electrons, means 2 electrons are being lost. And when I'm writing my reduction reaction here, reduction reaction means I'm going to go with let's erase this part also, and see HNO3, that's going to go into NO. And I know that 3 electrons are being gained. Now, balance each half reaction for all elements except hydrogen and oxygen. So in this equation, everything is already balanced. So I really do not need to do anything here. I do not have any hydrogens and oxygens there. But in this one, I have to see that I have 3 oxygens here. I have only 1 oxygen there. So how many water molecules I must add? So that remains the same thing here. For this one, H2O. That's going to bring 2 more oxygen. So now if you look at this, you have 1 oxygen here and 2 oxygens here. So 3 oxygens are balanced on both sides. So I have balanced my oxygen by adding the water molecules on the other side. Now I have an imbalance of hydrogen. On this side, I have 4 hydrogen, and this side I have already only 1 hydrogen. So I can balance it with by adding H pluses. Okay, so how many H pluses I must add here? 3 H pluses will be added on this side. Okay, so the equation, so this is being, we are continuing this one, right? But this one becomes 3 electrons plus 3 H pluses plus HNO3, and then that's going to be NO2 plus 2H2O. So now I have hydrogens and oxygens balanced on both sides, and then this is the equation here with copper. That's going to go into copper 2 plus, and 2 electrons are being lost. So balance each half reaction for charge by adding electrons, right? So we already have electrons here. All I need to do is to have them balanced. So I have to multiply this equation by yes, by 3, and I have to multiply this equation by 2. I can write a small 3 here if that's confusing. Now, when we do that, that's going to be 3 coppers and 3 Cu2 pluses. Why the font is not working well? Cu2 pluses plus 3 times 2, 6 electrons. Okay, on the other half, it's going to be 6 electrons plus 6 H pluses plus 2H, 2 HNO3, and that's going to be 2NO2 plus 4H2O. Okay, this is what we have done here in step 6. Multiply one or both equations to get it to equal number of electrons on both. So these are charged balance. And what we're going to do, we're going to add 2 half reactions and simplify that. So let's do, let's add them together. So that's going to be 3 copper, 3 coppers plus, not plus, it's going to go on to the right hand side. That's going to go into 3 Cu, my C is so awkward, Cu2 plus 6 electrons, right? And my other equation is 6 electrons plus 6 H pluses plus 2 HNO3. That's going to go into 2NO2 and plus 4H2O. Okay, so what I am able, so now canceling the similar stuff on both sides. I'm going to cancel these electrons. What else am I supposed to cancel here? Nothing, right? I cannot cancel anything else. So I need to write, just add them together. 3 Cu plus 6 H pluses, and then plus 2 HNO3. On the right hand side, I have 3 copper, 2 pluses, plus 2 NO2 plus 4 H2O. This is the balance equation that we have. You can see all the atoms and electrons are all balanced on both sides. That's why we're able to cancel the electrons on both sides. So 3 copper on the left hand side, 3 copper on the right hand side. 6 hydrogens, you have 4 times 2, 6 hydrogens here. You have, oh, just a minute, 8, what I'm doing. Haha, this is H, okay? So HNO3. So 2 hydrogens here, 6 hydrogens here, 8. 4 times 2 is also 8. So hydrogens are balanced. Then nitrogen, I have 2 nitrogens here. I have 2 nitrogens here. 2 times 3, 6 oxygens. I have 4 oxygens here and 2 oxygens here. That is also when it became NO2, it was NO only. Ha ha ha. See, that is the mistake I did throughout. I was not supposed to add a 2 here. Otherwise, it's not going to be balanced. Why I'm adding 2 here? It's just nitrogen monoxide, not nitrogen dioxide. Right? So I have my oxygens balanced on both sides. I have 2 oxygens here and 4 oxygens here. The total 6 hydrogen on the right hand side, and then 2 times 3 oxygens on the left hand side also. So this is a balance equation now. So at the end, when you are balancing, it is a very important step that you look at all the atoms are balanced on both sides. I did that and I found out my mistake here. Okay, I picked it up. So this is how exactly you're supposed to do it, because I was not NO2, I was NO only. So you're going to practice this one. It's very, very similar to what we have already been through. So do that one and you will get some points for that, extra credit points for that. Okay, so balancing the redox reactions occurring in the basic solution. This is the second way. So the first thing that we were doing, we were trying to balance the oxidation reduction reactions in acidic solutions. And now it's just one extra step for the basic one. You remember when we were discussing the steps of balancing the redox reactions, we did discuss that part, that whenever it's going to be the basic, there's going to be an additional step. Why? Because we have to balance the added hydrogen ions that we are not balancing in the acidic equation, though. Yes, so we have to go through the steps, and I'm trying to find out where my steps are, right here. If the reaction is done in the base after adding hydrogens, you have to neutralize this hydrogen by adding hydroxides on both sides, okay? So let's see what we can do here. What are we doing here? So this is the equation. This is a reaction, the redox reaction happening in the basic conditions here. So now we have to figure out exactly how we figure it out, that where oxidation is happening, where reduction is happening. So this is pretty easy to figure it out for iodine, because iodine is becoming neutral on the product side. So it's going to go from -1 to 0, which means it is a loss of electron that brings us to the oxidation. So definitely reduction is happening on the second reactant here. There are only 2 reactants here, but we have to do the oxidation state for all the atoms present in it, in the molecule. So we figured out what is being reduced here. Okay, so manganese we have and oxygen we have. That each oxygen is -2. -2 times 4 is going to be -8, but the sum of all the oxidation states should turn out to be equal to -1, and that's why we have to consider that manganese is +7, 1 less than oxygen. So the +7 -8 is going to give you -1. That's why if you look at the manganese from this side to that side, so -2 times 2 is -4 for oxygen total. That brings manganese to +4. From +7 to +4 means gain of electron. How many electrons are being gained in this one? Is in this reduction reaction is 3 electrons. That's why the oxidation number is dropping here. It's going down from +7 to +4. So guys, the second part here is to write down your half reactions. You can, it's your choice. If you want to add oxygen right now, you want to show your oxygen in the, if you want to show your electrons in the half reactions, you can do it right now. You can show your electrons right now. So oxidation means loss of electron, and loss of electron means how many electrons are being lost here. So that's going to be 2. If I balance it, 2 ions here, and that means it's going to be the loss of 2 electrons here. Okay, and this is manganese O4. It's actually the 3. It's actually the gain of 3 electrons here. So I'm going to show 3 electrons here on the reactant side for the reduction reaction. So see, this is how balanced it is here. And this is how this is here. And now balance all elements other than the step here. Balance all elements other than oxygen and hydrogen. So this is already balanced. Here we have manganese. Um, okay, I have to balance my oxygens here. I have 2 oxygen on the right hand side. I have 4 manganese are balanced. So, okay, manganese are balanced, so nothing to do with the manganese, but oxygens are not balanced. It means we are supposed to add water. So we have 4 oxygens here, only 2 oxygens here. So we'll add 2 water molecules on the right hand side. Correct? This is exactly what we did. Okay, there's going to be only last step that's going to be different in the basic solution. Okay, now we have 4 hydrogens on the right hand side and no hydrogen on the left hand side. So we have to add 4 hydrogen ions on the left hand side. Now, because it is now at this step is going to be an acidic equation because you have 4 H pluses. You know the H pluses are going to make it acidic. So now in the basic, if the question is asking you to balance it in the basic solution or basic conditions, you have to have one extra step where you have to neutralize your added H pluses with the added hydroxides here. Okay, so the H pluses and hydroxides equimolar of both is going to give you the water molecules. That's how you're neutralizing it. But make sure when you're adding hydroxides, you're going to add hydroxide, same number of hydroxides in both sides. Okay, so you're adding it here and you're also adding it here. So balance each half reaction with respect to charge because we had 2 electrons here, we had 3 electrons here. So you know this equation is going to be multiplied by 3 and this equation is going to be multiplied by 2. The same way we have been multiplying it. See, exactly 3 and exactly 2 is what you are going to multiply it. After multiplication, this is what is happening to the equation. And exactly like this is after multiplication, what is happening to the equation. The next step is the addition of 2 half reactions after balancing the electrons by multiplying both equation or either one of them. Depends on what reaction you are working with, which reaction you're working with, what is the situation here. But here we have to multiply both the first equation by 3 and the second equation by 2. And then we are all set to add them together. And then we have to cancel the similar stuff on both sides, right? So when we do that, we can cancel the electrons right away. But on this right-hand side or left-hand side, I have 8 water molecules. On the right-hand side, I have 4 water molecules. So these 4 are going to cancel 4 out of these 8. So the remaining water molecules are going to be 4 here. That's all. I have to just write down the remaining stuff down here. And you see there's some remaining hydroxide that says that this is in basic situation, in basic condition, basic solution. This is exactly the balance equation is. You can always count your number of atoms and your number of electrons. And that is the last step. But this is the main step to make sure that whatever you have done is perfectly all right. Okay, so now this is an example for which the solution is already provided to you. It's going to work for you as a reference for all the solutions that you are doing, all the balancing that you are doing for the redox reactions. So this is where we are going to work on it. And this is the complex equation. Let's say write the balance equation representing reaction between aqueous permanganate ion, which is MnO4 minus. Okay, and solid chromium hydroxide, which is CrOH3, to yield solid manganese. Okay, what is being formed? Solid manganese is being formed, Mn, solid, neutral, plus, oh, sorry, it says solid manganese oxide. I didn't read that. So reading is also important. You yield solid manganese 4 oxide, okay? So MnO2 and aqueous chromate ion, which is CrO4 2 minus. So this is the reaction that you are supposed to write after reading the question, and it's asking you to balance it in the basic solution. The first thing is to see what is being reduced, what is being oxidized. That is what we do exactly, right? So what happened to manganese and oxygen. So we have to figure that out. This is 4. 4 times 2 is 8. So oxygen is -2. -2 times 4, right? So let's do it here. -2 times 4 is going to be -8. And you know the sum is going to be equal to the charge on the ion. So that's going to be -1. So manganese is +7. So what happens to manganese from here to here? It's exactly the same thing. It's 2 minus 2 oxygens you have. So it's going to be -2 times 2 is going to be -4. So manganese here is +4. So manganese from +7 to +4. What's going on? Gain of electrons. Oh, what did I do? MnO4 minus. Gain of electron means reduction is happening here. +7, 2, +4. Loss of 3 electrons. Do not forget that. So I can quickly write down my reduction equation here, which is MnO4 minus. From here, because it's reduction is always the gain of electron. That's going to go into MnO2, correct? MnO2. It means it's a gain of, and I always write my electrons right there. So I'm writing it. It's up to you. If you know, add it after balancing the hydrogen and oxygen, it's up to you. But it helps me understand what I'm doing. So that's going to be the gain of 3 electrons, right? So now the second part is where the oxidation is happening. So I have chromium hydroxide here, chromium hydroxide. So what is happening to the chromium on the left-hand side? What is happening to the chromium on the right-hand side? This is exactly what we're supposed to know. So each hydroxide is -1. 3 hydroxide means it's going to be, so here 3 hydrogen means +3, and 3 oxygen means -6. That should turn out to be equal to 0. That means chromium is also +3. So +3, from +3, chromium is going into, this is 4, this is an ion, right? So the -2 times 4 means -8, but the equal should be equal to -2. So the chromium is +6 here. So from +3 to +6 is the loss of 3 electrons, right? So when we are writing CR, I'm gonna do it in blue. Erase first and then write. What is this? CrOH3. From here, it's gonna go into CrO2 minus, and that's 4 here, plus 3 electrons are being lost. One good part is that we have same number of electrons on both sides. Okay, so the next step after that is to balance all the atoms on both sides other than hydrogen and oxygen. So on my left-hand side, I have chromiums. That is chromium, one chromium on this side, and it's just one on both sides. That seems fine to me. And when I look at the manganese on the other side, they also look balanced also. They are also balanced. Manganese, there's no problem with the manganese. There's just one manganese on this side and the one manganese on the other side. The same way, I have one chromium there and one chromium on the other side. So these items are balanced. Now it's time to balance oxygens first. What I see on my left hand side, I have 3 oxygens on the right hand side, 3 oxygens here and 4 oxygens here. It means I have to add a water molecule on the left hand side, right? It's going to be H2O plus CrOH3. And that's going to go into CrO4 2 minus plus 3 electrons here. Sorry. Plus 3 electrons here. All right, so on my right hand side with my reduction reaction, I have 4 oxygen on my left hand side and only 2 oxygen on my right hand side. It means I have to have it as MnO2 plus 2H2O. So it's now 4 oxygens on the right hand side, means I can have 4 oxygens here as Mn plus 3 electrons. Now, it's definitely going to be an imbalance of hydrogens. So I have one oxygen and should be out of parentheses, right? That means 3 oxygens there. So I have to add there are 5 hydrogens on the left hand side and no hydrogen on the right hand side. So that means I have to make it 5 H pluses plus CrO4 2 minus plus 3 electrons. Right? And on this side, I have the same thing, CrOH3 plus H2O. And my chromium hydroxide is looking very weird, so I have to correct this part because H2O plus CrOH bracket parenthesis 3 and make a nice arrow. Oh, this seems like it is quite balanced now. Okay, and then I have to add H pluses on this side. Just 3 electrons plus how many hydrogens? 4 H pluses, correct? So it's going to be 4 H pluses plus MnO4 minus. And then it's going to go into MnO2 plus 2H2O. Now I'm supposed to multiply. So the oxygens are balanced, 2 oxygen, 2 oxygen, 4 oxygen on the left-hand side, 2 times 2, 4 hydrogens on the right-hand side, 4 hydrogens on the left-hand side. Everything looks balanced to me at this point and looks nice. I have 4 oxygens here, 4 oxygens here. You know, I have to make sure before I jump onto the next step that everything looks okay, everything is balanced. Now, if all oxygens and hydrogens are balanced by adding water molecules and then adding hydrogen ions, then, and I'm done with this step for your kind information, right? Then balance each half reactant for the chart. So I have to multiply. I really do not need to multiply these equations with anything because I already have the same number of electrons on both sides. Okay, so I'm good. It means I'm supposed to now, if necessary, you will multiply it, okay? I've already, so I do this step first, so I already have added my electrons there. So I really do not need to add my electrons at this step. So I've already added them previously. Now, balance. If necessary, multiply one or both equations. There is no need to multiply them. Just add them together. And adding them together means cancel the electrons on both sides. So I'm going to write down my equation number H2O plus CrOH3. That's going to go into 5H pluses. And then it's going to go into CrO4. That is 2 minus, and then plus 3 electrons. Here I'm going to start with 3 electrons plus 4H pluses, 4H pluses. And then it is MnO4 minus, and then it's going to go into MnO2 plus 2H2O. Okay. Where's my sheet? Sorry, what I'm doing. Sorry, I've lost my window somewhere, trying to figure it out. I have to stop sharing for a minute. Did I close the presentation? What happened to my presentation? That needs to be here. Yep, it's here. Sorry about that. So I'm all good to go with it. So we were here. What we will do, we will cancel the similar stuff on both sides now. So we have 4 hydrogens ions here, which are going to cancel 5 here. So 1 hydrogen ion is remaining on the other side. I have 1 water molecule that's going to cancel 1 here, and 1 water molecule is remaining on the right hand side. And then I'm going to simplify. And my electrons are also being canceled, right? So the simplification is going to give me MnO4 minus plus CrOH3, and that is going to give me H plus CrO4 2 minus plus MnO2 plus H2O. Now remember we were working in the basic solution. If the reaction takes place in the basic medium, add OH minus ions. The equation obtained in step 7 to neutralize the H plus ions. Okay. So we have to add, let's say, OH minus, because I have to add OH minus because just I have only one H plus there. So plus sorry, and the red thing is not working well, so I'm going to use a different color. That's going to be MnO4 minus plus CrOH3, and then you're going to be adding plus OH minuses. And that's going to go into H plus OH minus plus CrO4 2 minus plus MnO2 and plus H2O. So many things. you know that this is going to make more water here. Yes, so as I said, this is going to make one more water molecule. There's going to be two water molecule on this side then, okay? So we have to further simplify that. And because I do not have a space, I'm going to use this space now to further simplify it. Okay, so the final equation is going to be, this is MnO4 plus CrOH3 plus OH minus plus H2. So this H2O, this H2O together is going to be, oops, not plus, it's going to be the arrow now. So that's going to be the arrow, means you're going to have two H2O molecules plus CrO4 2 minus plus MnO2. That's going to be your balanced equation at the end. So this requires a lot of practice, actually. And once you practice it, you will start doing it. Okay, it's the same steps that you are going to follow again and again. It's nothing big in it. All you need to do is to just follow the same steps. And you must follow the steps. Okay, without the steps, you see, we are following the steps and it takes us long. It's going to take some time to balance the chemical equation. Rather, you just do not follow the steps and start doing it at your own. Most of the students, what I have experienced so far, what my experience is that the students are really lost if they are not going through the steps. So please, my suggestion is that please follow the steps. Okay. So what we were trying to talk about is this thing here. Finally, now you have a practice to do for the same thing where you're going to write the balance equation for the reaction occurring in the basic medium. So step remains the same if you are not making a mistake, because there's a lot of things that you have to do, adding hydrogens and then adding hydroxides in the basic one. So make sure that every step you pay extra attention and you make sure that you're not making any mistake. Like I was making sure that every step that I'm not making any mistake. Otherwise, I'll be lost. And if I just backtrack it, try to troubleshoot it, it's going to take longer for me that where I'm making the mistake. So it's better that every step you make sure that you're doing things correctly and everything looks fine, and then keep moving forward. It's going to take you to the balanced redox equation, which must be charged and mass balanced. So that is all for balancing the redox reaction. The next half of this chapter is about the galvanic cell, and that is what I plan to cover in class in person. Okay, so please, before you come to the class, make sure that these two now you practices must be completed on your paper, so you can turn that into me while you will be working on other extra credit problems. Now you practice problems in your class when we are going to meet on Wednesday. So before you come to the class, make sure that these two are done on your paper, and then you're going to continue with the rest of the practice problems, and you can hand it over to me. And that's for the extra credit though. But extra credit makes the difference, right? So put some efforts in and get points. Okay, guys, see you on Wednesday.